everybody. Have you ever wondered if somehow we could change the natural colors of flowers? Well, in this experiment, we will find out if this is possible. For this experiment, we are gonna need 8 small glasses. I cut 8 water bottles in half. 4 food coloring drops, water in a jar, and measuring cup, a measuring spoon, 6 carnation flowers, and either knife or scissors to cut the flowers. Make sure that when you are going to do this experiment, an adult is supervising the cutting of the flowers. So, for the sake of time, I have already prepared 6 of the 8 glasses we are gonna use. I will show you how I'm gonna do preparing the yellow color. So, we pour some water on the glass, then using the measuring spoon, we add half a teaspoon of the food coloring drops and complete with water. Now we are gonna cut the flowers with the scissors or the knife. I'm gonna use the scissors. We're gonna cut them about twice as tall as the container. And we start putting the flowers into the colored solutions to see what happens. Yellow, red, green, and blue. These flowers, we are gonna leave it for about 8-10 hours just in one color solution. For the other 2 carnations, we're gonna split the stem of the flower split it in 2 carefully. And we're gonna put each half of the flower into one leg, or in this case the yellow color, and the other half in the red one. The same with the other one. Try to split it in 2 the best we can. And in this case, we're gonna put it into the green and blue solutions to see what happens. Okay, welcome back. We have left the flowers in the color solutions, the carnations, for 24 hours, and now we are going to see the results. We kept carnation without any coloring, just for the purpose of comparison with the specimens we put into the color solutions. We can see, for instance, in first place, the carnation in the yellow solution. The color has reached all the petals to the top, and this means that the solution has gone through the stem up to the borders of the carnation. The green, we can see that the same case, the color goes all the way from the center of the petals to the periphery of the carnation. Same result with the blue, and finally we can see the red one. Very, very nice color. And what about the carnations that we split it into the stem and put it into one each half in one solution? First, we are going to see the carnation that we put in the yellow and red solutions. We can see that about half of the carnation gets the yellow color, while the other half has a very, very nice red color. So that means that each half of the stem suck up the color solution. On the left, the red one; on the right, the yellow. And finally, with the blue and red, we get similar results. Half of the carnation with a blue color on the right, and the other half with a with a green color. What is the scientific principle behind the experiment we just made? Well, flowers, like all living things, need water to survive. In our case, the flowers get the water from the glasses. Their stems suck up the color water all the way to the petals. This way, the color of the flowers was changed. In real life, plants do not have so much water as in our experiment, but still the water available in the ground is sucked up by many tiny tubes in the roots using a physical process called capillary action. Thank you so much. See you soon. Hello everybody. In a previous experiment, we saw how a steel needle can be magnetized by rubbing it with a magnet. But could it be possible to transform a metal into a magnet without using magnets? Even better, could we switch this property, magnet, non-magnet, at will? Well, we find out this question in this experiment. For this experiment, we are going to need a screwdriver. I'm using a wrench with a long shaft. It's the same. A battery of 9 volts, insulating tape, some alligators for the electrical connections, clips, metallic clips, to test that our experiment is working well. Insulated wire, copper wire, to to create the coil that will produce the magnetism, and a wire cutter. Also is wire stripper cut. First, we are gonna cut about 1 inch of the insulating wire to make the electrical connections. Okay. Now we have to stick this end of the wire to the base of the handle of the screwdriver, and we are gonna fix it with a insulating tape. Okay, so we're gonna stick tightly the wire to the handle of the screwdriver. So, okay, and now we are gonna start wrapping the wire around the shaft. We are gonna do it tightly, and we are gonna need about 60 turns to get a good coil for our purposes. Okay, we are finishing the wrapping of the copper wire around the shaft of the screwdriver, and now this end we're gonna fix it with some insulating tape just to keep it in place. Okay, now we have ready. We just have to peel off the other end of the wire. Okay, and now we are ready to make the electrical connections. We're gonna use these alligators to make the electrical connections with the battery, 9 volts battery, and we're gonna do it connecting both ends to the terminals or poles of the battery. Okay, now when I will connect the other end of the battery, we will see what happens with the wires. We can see that our screwdriver is working like a magnet, attracting the clips on it, several of them. But as soon as we disconnect the electricity flowing from the battery, the magnetism is off. So this is the main characteristic of these called electromagnets. They can be converted into a magnet by using electrical force. And when we don't need it as magnets, just turn off the electricity. What is the scientific principle behind this experiment? Electricity and magnetism are very closely related. Anytime electricity flows, a magnetic field is produced around the electrical conductor carrying electricity. Copper coils wound around a core, like the one we made in the experiment, create a strong magnetic field. However, when electricity is turned off, the magnetic field disappears. This on-off magnetic property has found countless applications in modern industry. Loudspeakers, disk drives, medical scanners, and levitating trains are just few examples of electromagnets applications in our society. Thank you so much. See you soon.